Today we are going to start 9.3. So given y equals fx in rectangular system, the arc length is given from a to b, integration from a to b, square root of 1 plus y prime squared dx. We are integrating about x. And if the parametric equation is given, x is a function of t, y is a function of t, the arc length formula, integration from t1 to t2, square root of dx over dt squared plus dy over dt squared. We are integrating about t here. For example, set up an integral expression for the arc length given from 0 to 1, given x and y here. So the arc length formula, 0 to 1, square root of dx over dt squared plus dy over dt, which is 12t squared dt. So this is the answer. So in this lesson, there are some type of very important problem, PVA problem related to vectors on the next page. So given if we put x and y together, this is what we call the position vector. And when we take the position vector, dx over dt and dy over dt give us the velocity vector. And we will take the velocity vector derivative, give us acceleration vector, second derivative with respect to x and y with respect to t. And the magnitude of the position vector is square root of x squared plus y squared. And the magnitude of velocity gives us the speed. Is given by square root of dx dt squared plus over dy over dt squared. And the distance and the displacement, displacement and distance, the total distance from t1, displacement from t1 to t2 is given by integrating the velocity vector v1 and v2. So it's integration t1 to t2 v1 and v2. This gives us x and y. So given xt1, how do we get xt2? So xt2 equals xt1 plus integration t1 to t2, the root of x, which is v1t dt. And the total distance traveled by the position vector is given by integration v1 squared plus v2 squared. This is the integration of the speed. Give you distance, which is the same thing as the arc length formula. Let's have a look at example 1. Given x and y and parametric equation, find the length of the path. So this is the arc length formula or the distance. Same thing as the distance. So the distance arc length formula from 0 to 1, square root of dx over dt, which is t squared plus dy over dt, which is t squared dt. So the answer will be C. Now let's have a look at the two AP problems example here. Given dx over dt, you have to read the problem carefully, and dy over dt, the derivative already given. This is the velocity vector. At t equals 1, the object is at t3. That means x1 equals 2, and y1 equals negative 3. Part A, find the equation of the tangent line. So we need to find the slope equals dy over dx, which is dy over dt divided by dx over dt, which is secant over tangent. You can simplify a little bit at t equals 1 and plug into your calculator, give you 2.781. So the equation of the line y plus 3 equals 2.781 times x minus 2. Part B, find the acceleration vector and the speed of the object at t equals 1. The acceleration vector is the derivative of the velocity. So the acceleration vector is given by d tangent e to the negative t derivative and the secant e to the negative t with respect to t at t equals 1. So you can use the math button on the graphing calculator, math number 8, to take the derivative and plug t equals 1 in. We get negative 0.423 and negative 0.152. And the speed of the object at t equals 1 This gives us square root tangent e to the negative 1 squared plus secant e to the negative 1 squared. Plug into your calculator, give you 1.139. Find the total distance traveled by the object over the time from 1 to 2. The distance formula, which is integration of the speed, square root of tangent e to the negative t squared plus secant e to the negative t squared dt, and you can use the calculator. The distance is about 1.059. And the last part, is there a time t at which the object is on the y-axis? This one's a little bit difficult. So if you look at the point on the y-axis, we know x has to be 0. So we are looking for, is there a point t, x equals 0? And we realize dx over dt is given, which is tangent e to the negative t. And also at x equals 1, the position is at 2. So the slope, dx over dt given, dx over dt gives us the increased rate about x with respect to t. And we look at the graph, it's always positive. That means x is always increasing with respect to t. So as long as we find the smallest number, okay, from 0 to infinity, if the smallest number is negative, that means there will be a point, x equals 0. Otherwise, there will be no point. So let's have a look at what is x of 0. Because x of 1 equals x of 0 plus 0 to 1. Tangent e to the negative t dt. We plug everything in, so x1 equals 2. And we evaluate it. We get x of 0 equals 1.224. So because x0 is positive and dx over dt is always positive, so that means x increases as t positive. So there's no x equals 0. Let's have a look at next AP problem. So given the graph, a particle starts at A at t equals 0, and the particle goes along the curve from A to B, B to C, and C to D. And the coordinates x prime and y prime are here. At t equals 9, it got D, so t equals 9 here. Part A, at point C, is dy over dt is positive, or dx over dt is positive. If you look at point C here, so point C here, because from point C, the y value is decreasing and x is also decreasing. So dy over dt has to be negative. So as at point C, y decreases. So dy over dt is not positive. Same reason, because C is going to D, so x also decreases. So dx over dt is not positive. Part B, the slope of the curve is undefined at B here. There's no slope here. And what time t will be the point B? So the slope m equals dy over dt over dx over dt. So the slope is undefined. That means at B, dx over dt equals 0. So we set dx over dt negative 9 cosine pi t over 6 times sine over 2 here. And we find the 0. We plot this and find the 0 of this equation. So t equals 3 here. Part C, The line tangent to the curve at x prime, x8 and y8 has an equation y equals 5 over 9x minus 2. Find the velocity vector. So the velocity vector is given by x prime at 8, y prime at 8. Because x dx over dt is given x prime 8, we can directly plug it in. So your calculator gave us negative 4.5. So now we need to solve for y prime at 8. Because the equation of the tangent line is given, so slope equals 5 over 9, which is given by dy over dt. So y prime at 8 over x prime at 8. So y prime 8 equals, we plug x prime 8 in, negative 2.5. So altogether, so the velocity vector is negative 4.5 and negative 2.5. And the speed is given by the magnitude, which is negative 4.5 squared, plus negative 2.5 squared equals 5.148. Part D. How far apart point A and point D? If you look at here, point A is here, point D here. We are looking for how far away they are. So it's the same thing as the displacement change. So it's x at D minus x at A, which is x9 minus x of 0 equals 0 to 9 x prime dt. We plug this into a calculator, give us negative 39.255. So the point A and point D is 39.255 units away from each other.